So these next two examples take a little more manipulation before we can find those antiderivatives. So for instance, on number 5, I want to rewrite this as x to a power first. So this is x to the 7 over 2 power. Then this is plus 1/2 x to the negative 2 power dx. So now I can apply the power rule, adding 1 and then dividing by that power. So 7 over 2 plus 2 over 2 is 9 over 2. And if I divide by that fraction, that's multiplying by its reciprocal. And then x to the negative 2 plus 1 is negative 1. So I'll have x to the negative 1, and dividing by negative 1 will make this a negative 1/2 plus c. And we can simplify that answer, but I'm just going to leave it here to save time. And then last, this one, we have x to the square root power, which is x to the 1/2 power on the denominator. So if I subtract my exponents, 6 over 2 minus 1 over 2 makes x to the 5/2 power. 4 over 2 minus 1 over 2 makes x to the 3 over 2. And then this is minus 5x to the negative 1/2 power dx. So fractions always make things a little bit harder, but same idea, right? So adding 2 over 2 plus 5 over 2 makes x to the 7 over 2. Dividing by that fraction, we multiply by its reciprocal. And then subtract, oh, I was missing my x there. Adding 2 over 2 plus 3 over 2 makes x to the 5 over 2. And 6 multiplied by 2 over 5 makes 12 over 5. And then we're subtracting here. 2 over 2 plus negative 1 over 2 is x to the 1 over 2. And dividing by 1/2 is multiplying by 2, so this is 10. And then don't forget, indefinite integrals is a family of functions plus c on the end.